Part B of this experiment has us exploring the properties of triacylglycerols, and each of these test tubes is a sample of vegetable oil. To test tube 1 is added a little bit of water, to test tube 2 is ethanol, and added to test tube 3 is hexanes. Our initial observation is that there isn't much difference between the three test tubes. I'll agitate each one of them so that we can see a little more about the interactions between the liquids in each. As the solutions settle, let me remind you that again, in test tube 1 is water and vegetable oil, in test tube 2 is ethanol and vegetable oil, and in test tube 3 is hexanes and vegetable oil. For our next set of observations, we'll be adding potassium permanganate to test for unsaturation. Test tube 1 contains a solution of vegetable oil and hexanes. Test tube 2 contains a sample of Crisco and hexanes. At room temperature, the reaction between potassium permanganate and a double bond can take some time, so I've elapsed this video for about 45 minutes. As you'll see, one of these test tubes has definitely changed color over this time. For part C, we will be comparing the properties of a solution made from our lab-made soap to a solution made from a commercial laundry detergent. The first property we want to explore is that of pH. To each test tube, I am adding a little bit of phenolphthalein. Phenolphthalein is an acid-base indicator that lets us know whether or not something is acidic or basic. When it's pink, we see that the solution is more basic. If it were to be clear, we would say that the solution is more acidic. Being that phenolphthalein doesn't show us exactly how basic this solution is, we are going to use pH test strips. This should give us an indication of just how basic these solutions are. At this point, it's important to ask whether or not both of these solutions should be basic and what might contribute to this. The next property we want to explore is emulsification. We are going to add mineral oil to each of these test tubes. Test tube A has a soap solution. Test tube B has our detergent solution. And test tube C is our control, which contains water. To each of these, we are adding mineral oil. Our initial observation is that there's a separation between these solutions, so it's important that we agitate them to see how well these two solutions interact. It might be a challenge to see the difference between these test tubes. Look closely to see if you see separation between the solutions in the test tubes. Our last set of observations, we'll be looking at the effect of hard water on detergency. We'll be placing our soap solution into each of these test tubes, one containing magnesium chloride, one containing iron chloride, and one containing calcium chloride. Try to observe to the best of your ability whether or not you see precipitate in each of these test tubes.